What's up guys? Today me and my robot Waity, a mobile robotics platform for experimentation I designed for delivering food in restaurants, are going to show you what it takes to build a useful artificial intelligence powered robot. In this video, I'm going to talk about its construction and the process you too can also follow to build a similar robot at a reasonable cost. So stick around because that is coming up next. Let's get started.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Robotics has come a far way compared to where it was in the past. With robots like Spot and Sophia entering into the marketplace, we can see the technology has come a far way. If you're watching this video, I assume that when you saw these fascinating machines, you were interested in making your own. However, when you look through Amazon or AliExpress, robots we are able to buy and experiment with are these tiny Arduino-based robots. So the question is, how do you build one of these robots like Sophia or Spot at reasonable cost? And what does it take to build an advanced robot? Well, this is the question I'm going to answer in this video. Let me first make it clear. When you start to cross into the realm of building medium and full-size robots, it can get expensive pretty quickly. Things like dynamic cell robot servos, computer boards, and LCD displays can send your cost up pretty quickly. You don't believe me? Well, take a look at robotic platforms online. Whereas a Raspberry Pi or Jetson powered mini robot can be built for a few $100s, a robot like Spot or Sophia, or even a relatively large and cheap food delivery robot from China will cost, or at minimum, a few tens of thousands of dollars. That brings us to another point. What type of robot are you interested in building? Is it a humanoid robot, able to balance on two legs, walk upstairs, and do everything you saw in your favorite movie? Or is it a robot dog of some kind, similar to the Spot robot? Or are you more interested in mobile robots, like the food delivery robots you see in restaurants? Your choice of robot is the most important step. If you are now getting started on robotics, it is best to stick to mobile robots because you will break stuff. And not only are mobile robots less costly to build, they are also easier to model mathematically and to simulate. We will start by discussing the parts of the mobile robot. The main parts of a mobile robot are the body, power system, sensors and actuators, an AI system, and finally, skills and aesthetics. I call this the BP SASA design procedure, which can be used to design any modern artificial intelligence powered robotic system. When we put all these things together, we get an AI intelligent robot that we can program to perform certain tasks. The first thing you have to design is your robot body. Your body can be made from wood, metal, or plastic, or any combination of those materials. Stay away from exotic materials since they are costly and allow less room for mistakes. Make your prototype in materials such as metal or plastic, and then switch to more exotic materials once you have finalized the design. Once you have decided what material you want the robot to be constructed from, the next thing you want to do is actually design the robot. You will need to create a computer-aided design or CAD model. This is to ensure that all your parts align well and fit together perfectly in the final design. You can use tools like SolidWorks or Inventor to develop a CAD model of your robot. I personally use SolidWorks. These tools are costly and have a steep learning curve, but the investment is worth it once you continue into robotics engineering and design. As an added benefit, once you learn these tools, you'll be able to apply these skills to designing other things besides robots. Once you have finalized the design, you can use 3D printing and a CNC machine to build a prototype. I recommend a combination of PETG or ABS for plastic and 30035052 or 6061 aluminum for metal, as these are low cost, strong, and lightweight material, a property you'll need for a robot. The next part of your robot you must consider is the power supply. This is usually overlooked, but the power supply can be thought of as the heart of a robot, responsible for pumping electricity, which is akin to blood, from your robot. It gives your robot vitality and energy, and the wires that distribute power are like arteries. This must not be overlooked. Your entire system and subsystems are all based on the type of power supply you use. For a mobile robot, you want to use batteries, and some common battery chemistries are lead acid, lithium ion, and lithium iron phosphate batteries. There is always a trade-off in your power supply. Lead acid batteries are low cost and add weight to your robot. Lithium ion and lithium iron phosphate batteries are lightweight and have a high power density, but have restrictions on shipping and are costly, particularly if you are living in a developing country. You also have to think about things like buck or boost converters and drawing block diagrams and schematics that lay out how power will be distributed in a robot. Today, it is possible to get robotic sensors that can mimic all the senses of a human, which are touch, sight, hearing, smell, and taste. Unless you are building a specialized system for interfacing with organics, your robot will usually get by with sight, hearing, or touch, and any combination of both. Though in our case, sight and hearing are the aspects we'll focus on. This usually means having a camera for sight and a microphone for listening to audio. There are ultrasonic sensors, infrared sensors, and things like LiDAR you can equip your robot for it to sense its environment and perform things like obstacle and edge detection. Actuation is another important step in designing a robot. Motors are used for locomotion and speakers for communication. These are critical in allowing your platform to interact with the physical world. Usually, you want some type of microcontroller board to control the motors and simpler sensors, and a single board computer to interface to the camera and microphone. In the case of WATI, we use the mini ITX motherboard to interface to the camera and a microphone and Arduino board to control the motors and other sensors. Once you have completed the physical parts of the robot, the next step is to give it artificial intelligence so that it can interact with its environment. By artificial intelligence, we mean we can give a robot the ability to reason, adapt, and provide solutions to problems in our world. The type of AI system you interface into your robot will depend on the compute power you have on board the robot, as well as the task you want the robot to perform, as well as the available technology you have at your disposal. You can use a narrow AI system or a weak AI that is focused on only one task, and this may be a focused narrow, hybrid AI, or multimodal AI system. You can also use a general intelligent or strong AI system to power a robot. In the case of WATI, uses a focused, narrow AI system due to cost constraints, compute power available, and limitations of existing technology to interface it with a strong AI system. The purpose of the AI WATI uses is to allow him to perform localization, mapping, and semantic navigation using a monocular-based visual odometry system combined with a custom inertial navigation system I designed so that he'll know where he is, where he has to go, and how to get there. Thanks to the provision of ultrasonic sensors and object recognition through his artificial intelligence system, WATI knows how to avoid obstacles and detect people on its way to its destination. The final thing you must be able to do is provide some skill or service to end users. This seems counterintuitive, as you would design your robot to be suited to the task you have in mind for it usually. However, most roboticists and robotics engineers will get a platform already built or perfect a simple platform of their own design and then adapt it to the task at hand adding or removing what they want from the platform, and then programming it with the skills needed to accomplish a task. This means that the same robotic platform may be used in the service or construction industry or even military applications, depending on how you adapt and modify the platform. Take a drone for instance. We can use a drone to take aerial photographs for personal professional use. That drone can also be used in the oil and gas industry for inspecting pipeline integrity, and in the military it can be used for battlefield surveillance. In the case of Waity, he must be able to deliver food in restaurants or supplies in nursing homes and hospitals. He can also distribute giveaways and merchandise at trade shows or events, or greet customers as they enter into a store, telling them about the daily specials. And finally, your robot must also have an appealing look. You can go for an industrial look. You can design a robot to have a realistic look, like an animal or human, or in the case of Waity, he was designed to look like a robot. Keep in mind that better looking aesthetics cost more, but does not add functionality to the robot. It is simply for a better experience conducive to good human-computer interaction design. I hope this video provided you with an overview of what you need to be able to do to build your own advanced robot similar to Waity. I plan on doing the entire series, going over each of these facets in more steps. So be sure to like, subscribe, and click the notification bell so that you'll be able to follow along with the process. And if you have any questions, you can comment below. If you want to help me in my mission of making robotics free and available, be sure to support me on Patreon and share this video. That's it for now. See you next time.